Hey everybody, welcome back. In this video, I'm going to explain a method for graphing quadratics from tables. Specifically, we're looking at how to graph parabolas using quadratic functions and with very little intervention and assistance from other strategies like getting the axis of symmetry formula or the quadratic formula or factoring or any of those methods that help us to find things like the zeros or the x-intercepts of these parabolas or the vertex location. Instead, we're going to look at how to graph these using only a table and very basic knowledge about quadratic functions and what they have to offer. So with that, let's go ahead and begin. So we have an example one, this quadratic function that you see here. And one thing that strikes me right away when I look at this is it's telling me the direction that this parabola is going to take. Now I'm going to sidestep for just a moment so I can illustrate this for you. When you have a quadratic function, first of all, a quadratic function looks like this, as you might remember. And the leader of this quadratic function is always going to be the coefficient attached to your x squared, or your square term, as it's also known. So in this case, that would be whatever value that letter a takes. When the letter a is something that is greater than 1, in other words, it's a positive. And I'll put it that way. So if it's a positive number, then what that means is you're going to end up with a parabola that looks like a smile. And if your a is negative, you're going to end up with a parabola that looks like a frown. Now, what I like to say is, to help remember this, is think of a leader. So in this quadratic equation, you have a leader that is your a. And just like with people, we like leaders who are positive. A positive leader tends to smile, and a negative leader tends to frown. So if that helps you to remember the little trick right there, if that helps you to remember in which direction the parabola is likely to end up, then please, by all means, go ahead and use it. It does work for me, and I like the analogy as well, as we can all relate to things like that. So coming over here, let's take a look at our function once again. So we have f of x equals x squared. Now, at first glance, it may seem like there is no leader here, like there's nothing, but there actually is, and it's a number 1. So being that we have a as a value of 1, that means that our a value, or our leader, is a positive. So I'm going to most likely end up, unless anything were to change this, which it's not likely to do, I'm going to end up with a parabola that looks like a smiling face. So this is going to be the recurring thought in the back of my mind as I'm trying to piece together the way this picture looks at the very end. And if you look also at the space that you're given to work with, it logically makes sense that you would have a smiley face instead of a frown. And that's because you are mostly given quadrant 1 to work inside of. And that's all positive values for both x and for y. Now, yes, we do have a negative right here for our x, but you know, that's very, very little space, and we're not likely to actually cross into that area when we're completing our picture here. So a couple things to guide you along, just as you're trying to formulate in your head what this thing will look like. Okay, so what do you do if you don't know any of the tricks that I mentioned at the start of the video? How do you graph something like this? Well, the answer to it is there is very little that you need to know how to do other than a couple things. Number 1, you need to know how to make a table. Okay, so these are the things that you need. So make a table, and when I say table, I mean an input-output table. So also known as an XY table. Okay, so an input-output table. Also, you need to be able to substitute and evaluate. So evaluating is when you substitute a number and you use the order of operations to simplify everything until you condense it down to one single value, most of the case in Algebra 1. So with that in mind, let's go ahead and take a look at one other thing that would help us to get started, and this is a little trick of the trade. So we get a free point by looking at the function, by looking at the very end. The last number, which is known as a constant, and it has no variable, this number is a free point disguised as a number 5. And the particular point that it is a y-intercept. Now there are two 5s, so be careful with this, okay? There's a 5 right here. There's also a 5 right over here, and it's often confused one with the other. Be wary not to do that, okay? So when we are looking at the last number in a quadratic function, the constant, we are looking specifically at this number, the y-intercept value. So I immediately get a point for free, having done absolutely nothing at all other than knowing that little trick. And I'm so tempted to go into the reason why this is the y-intercept, but I have to hold off on doing that. I will probably type it into my notes. If you want to look down below the video after you watch, you'll probably see it there. But it's worth checking out. Okay, it's not just some random fact. Anyway, this is the first point that we get, and it's a y-intercept. So that doesn't do a whole lot for us in terms of completing the graph. So we need a total of 5 points. So to get the other 4, we're going to go ahead and we're going to build a table for ourselves. A table. So here's my x. This is for my inputs. Okay. Right after that, I will have my expression, x squared minus 4x plus 5, followed by the outcome of the input and the result, which is the output. So my x and then y written as an ordered pair. Now, there's a bit of a strategy to this. I get asked from time to time, how do you know what values you should pick to put into your input side? Well, it's a very good question. And the answer to that is, if you're given a space to work with like this, you might notice that your domain is from 0 to 5, or technically it's from -1 to 5. At least that's the breadth of this workspace, right? So technically this parabola is going to stretch to infinity, but we are given a set of values to choose from, which is really nice because all we have to do is pick one and throw it into the table. So how do you know which one to pick? Well, our guiding point will be the very first one, which is our y-intercept. Okay, so at our y-intercept, our x value is 0 and our y value is 5. Okay, so if I know this is going to be a smile and my y-intercept is already a very high point, it's likely that my vertex, the lowest point, is going to be somewhere lower to the bottom, lower to this ground over here. I want to pick a number that is sort of in the middle of this space. So I'm going to go with the number 2. I don't want to go with a decimal. You're welcome to if you want to. You can grab a calculator and it would work out just fine. Just be careful what you press into the calculator. But I'm going to go with 2. And I'm going to put it right over here. Okay, now the reason I'm putting it down there is because I know when x is 0, I know I'm already going to get 0, 5. So I'm putting 2 there just so that it follows a sort of logical sequence as you go down the table. All right. In fact, I'm going to move it even further just so I can leave room for 1 if I need to. Okay, so if I plug in a 2, which is my number of choice, what I'm going to get is 2 squared minus 4 times 2 plus 5. Then I need to simplify this. So this becomes 4 minus 8 plus 5. And if you put all 3 numbers together, what you would get is -4 plus 5, which is 1. So this equals 1, and I get 2, 1. So I'm going to right away go ahead and plot the point at 2, 1. And again, it doesn't do a whole lot to inform the way this graph is going to look. I have 2 points, but that just makes a line if you were to connect them together. And I'm definitely going to get a curve, as you can see from my face over there. All right, so then what do? We go ahead and grab another point. And the way to do this is you want to think, okay, if I know it's going to be a smile, and I know this thing is going to go from my y-intercept down this way, right? It's going to hit a low point and then swing back up again. I don't know exactly where that low point is. It could be that this is it right there, but I don't want to guess. I want to know. So what I'm going to do is I'm going to grab a number to the right side of 2 and plug that in over here. Let's see what happens. So this will be 3 squared minus 4 times 3. Do that again. 4 times 3 plus 5. This makes 9 minus 12 plus 5. And doing all the math, 9 minus 12 is negative 3, plus 5 is 2. So I get 2, and this is 3 comma 2. So 3 comma 2 puts me right over here. Okay, so now I can definitely see this is not going to be a line. This is going to be something other than that, because I have 3 points that are non-collinear or they're not in line together. And so what I want to do is now look back at this point, because the number to the right of 2 gave me a point that's higher than this, right? So if that's 2 comma 1 and I went 1 number to the right and I got a point that's higher than the one before it, then there's a pretty good chance this is the vertex or the lowest point of my parabola. So I'm going to go ahead and try 1 this time. I'm going to plug in a 1, and if I'm right, it should give me a point right over there. Let's see if I'm correct. I'm going to leave my arrow there. So 1 squared minus 4 times 1 plus 5. And I didn't give myself a whole lot of space to work with this here, so I'll just wrap it all up and get right to the ordered pair. So that's going to be 1 minus 4, which is negative 3, plus 5 is 2. So it's going to be 1 comma 2. And look at that. It's right over there. 1 comma 2. Okay? Strategy works. So as soon as, and here's another trick, okay? As soon as you see, hey, I have 2 points that are on the same level with each other. As soon as you see that, then all you have to do is get the middle place between them, and you know exactly where this parabola is going to get cut in half. And in this case, we also know one more thing. We know where the vertex is. So let me first go ahead and do what I said. I'm going to get the place in the middle. So the place in the middle is right over here. Draw my line. Again, this line represents the invisible line of symmetry where the parabola will get sliced in perfect halves. And it has a name, and it's called the axis of symmetry. So axis of symmetry. Okay, symmetry being sort of an artistic word, meaning you get the same thing on both sides. Our faces are more or less symmetrical. If you draw a line from your forehead down over the bridge of your nose down to the center of your chin, you compare both halves of your face and you would hopefully see that they are more or less identical. They're never completely the same. Okay, anyway, getting back to this. So I now have 1, 2, 3, and 4. I have 4 points. And I need 5, as I said earlier, to make a good picture. So this is really coming along. To get that 5th point, all I have to do is use this axis of symmetry as a mirror. Okay, it's like a mirror. Anything you show on one side, it gets reflected on the opposite side in exactly the same way, on the same level, the same number of spaces from that mirror. So if I go over here and I look at, hey, my first point, my y-intercept, and you count the number of spaces from that axis of symmetry, you can see it's 1 giant square, 2 giant squares, which means that its reflection is going to be 1 giant square, 2 giant squares, but on the opposite side. And that will give me a point right there. Totally free. So these 2 points actually were completely free. I didn't have to do anything at all. Nothing in the table, no calculation. So now we have 5 points, and I can go ahead and complete my graph. I'm going to draw this in with red for contrast here. So here we go. Remember, by the way, that when you draw parabolas, first of all, make sure you don't erase it like I just did. And if you do, just do it again. So remember, parabolas are not letter V's. They're not sharp and angular. They are graceful. They have a curve to them, a curvature. And in this case, our curvature lies at the bottom. So as soon as you hit that vertex, you switch directions and you move from going down to going up. Okay, that's not bad if I say so myself. All right, and our parabola is completed. One more thing that I would like to mention here, going back to the axis of symmetry, is that the way to write the axis of symmetry as an algebra equation would be to write it as x is equal to, and then you always put a number inside. The number inside is simply the input value on the x-axis that the line goes through. Another way of looking at it is that it's also the location of the vertex that it cuts through. So this would be 2, 1 in this case. That 2 you see right there is a 2 that you drop into the square over here. Okay? Right there. That's the equation for the axis of symmetry. It's always going to be x equals something. And the something and the x value of the vertex are always going to be the same. All right, and with that, we are done with this. And you can see definitely this is a smiley face. Okay, so if you wanted to enhance this in any way, add eyes, ears, eyebrows, whatever you want to do, go ahead, as long as your teacher is okay with it, of course. But I want to do one more example before we're done, and it's this one over here. So the first thing that strikes me when I look at this is, look at that over there, our leader. Not quite the same as it was formerly, right? So this time we have a negative value. The negative value is actually -1, and therefore we have a negative leader. What do negative leaders mean? Well, what do negative leaders do? Negative leaders, they frown. So we're going to end up with a parabola that is frowning or upside down like this. So I expect that from the very beginning. And unless something is going to come along and change this negative leader to a positive one, this is what I should end up with. Okay, of course, minus the eyes. All right, so let's go ahead and do the things that we did before. I'm going to look at the very last, going to look to see if I have a free point. And the very last number, there it is, +3. So for free, not doing anything, not even making a table yet, I already know, hey, I have a free point and it's at +3. Again, it's the y-axis +3 and not the x-axis +3, which in this case, you don't have to worry about anyway, since our x values are mainly negative. Okay, so if this is going to be upside down, then I need to think to myself, the vertex is going to be at the highest point. So remember, if it goes upside down, the vertex is not the lowest point this time. The vertex is going to be the highest point, something like that, which means that I have most of this space in which to draw my picture, okay? And it's going to cut through my y-intercept there and maybe, or maybe not, cut through my x-axis, okay? So let's go ahead and jump in. So now that I have my point, I'm going to create my table. Here's my input. And then my expression goes here. So -x² minus 2x plus 3. Then I have my input-output combination, or my ordered pair. All right, so as I did before, I know what happens when x is 0. I'm going to get a 3, so 0, 3. And actually, I should put this somewhere else. I'm going to put the 0 over here this time, okay? Because mostly negative numbers are on my x-axis, and that's what I'm going to be plugging in. So 0 actually will go down there. 0, 3 goes over there. So most of this space is going to be reserved for my negative x values. As you can see over here, that's mainly what you're given to work with. So it takes all the guesswork out of what numbers you should plug into the table. So I'm going to go with a number that's close to the y-intercept. In this case, that would be -1 or -2. And I'm going to go with -2 just to see what happens. Let's see what happens if you put -2 in there. Again, I'll leave space for -1, -2. So we're going to have, oh, and by the way, I should tell you, because I see this far too often, be careful with that negative in front. Be careful with it, okay? That negative is going to stand by while you do all this stuff. And you will only be able to activate this negative once you have finished doing whatever you need to do right there. So just keep that in mind, okay? You're going to see that as I work with the table. So here we go. It's going to be negative, then negative 2 squared, then minus 2 times negative 2. And I'm really running out of space here, so let's rewrite this a little bit. That's better. Much better. 0, 3. And then plus 3. Okay, so what I need to do according to the order of operations is I have to do this part first. So negative 2 to the power of 2 is 4. However, because of this negative here, it's going to turn the 4 into a negative 4. So now I have negative 4. Then I have plus 4. Then I have plus 3. Okay, now these two simply eliminate, and the result is I just get 3. So negative 2 comma 3. I'm having trouble writing my 3's today. There we go. Negative 2 comma 3 is my second point. So negative 2 comma 3 is right over here. Okay, and because I have 2 points on the same level, what this means, and this is good news, what this means, when you see something like that, 2 points on the same level, then you can right away get some extra information for free as well. And what I'm talking about is the axis of symmetry. So you go right in the middle of these 2 points and you carve out your AOS line, your axis of symmetry. There it is. I know exactly where this parabola gets cut in half. And I'm going to write the equation because it is an official line here. So it's x equals, and it goes through negative 1. So it's x equals negative 1, okay? That's the AOS equation. And I'm going to abbreviate AOS for axis of symmetry. All right, so this is good because what this tells me also is that the vertex is also going to sit on this AOS line. It always does. So I have to plug in negative 1 so that I know where this is going to be. So I'm going to put negative 1 over here. And it looks like I need to bump this down. So let's move it all down so it's nice and organized. All right, so 0 there, 0 comma 3. Okay, so negative 1. So you have negative first, negative 1 squared minus 2 times negative 1, and then plus 3. So negative 1 squared, okay, you do that first. That's going to be a 1. This negative will attach itself and make it a negative 1. And then you have plus 2 and plus 3. And putting all those together, what you end up with is a 4. So this is going to be negative 1 comma 4. And then you go to your table, you go to your space, your coordinate plane, negative 1 comma 4. Where is that? Right over there. Look at that. Right on the AOS line. Okay. So you have 3 out of 5 points. But this looks too much like a triangle. We need something that forces this design to bend a little bit, okay? So with 3 points, it's a little bit too rigid, and we want to definitely have 5 total. The nice thing is I have my AOS line, and all I need to do is grab another point on either the left or right side of my AOS line and plug that into the table. I don't need to put 2 more numbers into the table because I can now reflect points across that AOS line, and I get other points for free. So the one I'm going to grab is this negative 3 over here. So here we go. It's going to be negative 3. Plugging this in, again, negative first, then negative 3 squared minus 2 times negative 3 plus 3. And then you do the work. So do this first. That's going to be 9. But that negative over there at the front will make it a negative 9. And then you have plus 6 and then plus 3. Okay, now going left to right, negative 9 plus 6 is going to be 3. And 3 plus 3, negative 3. Let me go back again. Blah, blah, blah. Negative 9 plus 6 is negative 3. Negative 3 plus 3 is 0. So what I get is -3, 0. And this is a really interesting point because of where it's sitting. So -3, 0 is sitting right on that x-axis. It's sitting right on top of it. Anytime you have a point that sits on top of an axis, it's going to be that type of intercept. So either x-intercept if it's sitting on that one, or y-intercept if it's sitting on that one. As you can see right there, that was our first point. So I have an x-intercept point. Okay, and now I'm going to get my fifth and final point by reflecting it across the AOS line. So all I have to do is count how many jumps away I am. 1 big square, 2 big square. So therefore 1 big square, 2 big square, and I put my point right over here. There, free point. Didn't have to do anything. Okay, there, I have 5 points, and I can go ahead and create my parabola. Again, you want to make sure this is not sharp and angular, but more like a curve. So I'm going to actually start over there. It's going to sweep down and then try to mimic that on this side as well. Okay, cool. So there it is. So as you can see, we have 2 x-intercepts this time, and that's information that we should also make note of. So this is x-intercept number 1. It's located at -3, 0. This over here is x-intercept number 2, and it's at 1, 0. 1, 0, 0. I'm making it worse. There, 0. And there you have it, everybody. So let's do a quick recap. In the very beginning, we looked at graphing quadratics from tables as a way to create a graph without any extra knowledge that you might acquire later on, tricks of the trade, and so on. The only thing that might be of help to you is knowing that the last value, the constant, the one with no variable, is actually a y-intercept in disguise as a number. So you place that as a point, and then you make a table. The way to make a table is you simply open your x, drop in your function, or you can turn it into an expression if you want, get your output, combine it into an ordered pair, and you get a bunch of points, and then until you can see that you have 2 points on the same level. As you can see there, and you can see right there. As soon as you have 2 points on the same level, you can create what's called the axis of symmetry, which is the invisible line that cuts a parabola into 2 equal halves. Once you know this, you should also be able to figure out the location of the vertex, the most important point. And the vertex and the axis of symmetry have one thing in common, and that is their x values are always going to be identical to each other. So if you know one, then you know the other. We looked at a case where the parabola was upside down, and it was mentioned that the reason for this is due to the leader being a negative value. Negative leaders frown versus positive leaders smile. So that's a quick little trick to help you remember the direction it's going to take. We looked at x-intercepts in the second example, and we had to mark those and label it and give it our due respect, because these are also very crucial, important points. As you might learn later on, there are ways of figuring out the locations of these points using things like factoring, the quadratic formula, completing the square, or the radical method. These are methods that, if you don't already know about them, you are sure to learn about at least some of them in your math studies. I hope this video helped you better understand the steps required and the thinking behind this. As always, please stop by and leave a comment, and thanks for watching. Bye-bye.